Okay, I'm sorry. I'm just going to have to... Give me the problem. Now, what I need to do is tell the person that's in charge of the calculus to switch over to a decent website. That's what I need to do, because WebAssign just is so archaic. Yeah, that's the one I'm talking about. This is ridiculous. My lab plus. Yeah. What's the problem? While you're looking for your problem, I'll go ahead and pull up the section we're going to go over today, if it'll pull it up. Still pulls up business calculus book. This is so frustrating. I think we covered, yeah, we got everything we need to cover. Substitution rule. Still waiting on you whenever you're ready. Okay, we'll just do it at the end of class then.
Sorry about it.
Try to send it to me, and if you can, that way I can pull it up and won't have to go through and look. Okay? Alright, they give us this problem right here, starting us off, and I don't know how much substitution you did in Calc 1, but just going over it just to make sure that you understand, or that you know, knock the cobwebs loose. They're giving us the antiderivative of 2x square root of 1 plus x squared dx. And we'll take that and we'll copy it and take it over to the white page and just make everybody aware of how we do substitution. Alright, first thing I would do is make sure that it's written in an order that would help with the substitution, and that would be, put this over here, right here, so that would be the antiderivative of the square root of 1 plus x squared 2x dx. Now, if we make this inside right here, and you always want to take the inside and make that u, u is equal to 1 plus x squared, therefore du is equal to what? 2x dx. We already have 2x dx. So technically we have the square root of u du is what we have. We have the integration or the antiderivative of the square root of u du. Now, what you have to get used to with antiderivatives and with antiderivative substitution is this part right here. You have to get it, and the book don't say this. This is a Hubertism. You need to get it in some kind of order that will trigger you looking for that right there because of this. And you can't do that if this is sitting out front, and this is a kind of a helpful hint to put it in some kind of order. Usually your most complicated term should go first, and then this should follow, and then therefore when you take the u right here and you take the du, you'll see that it's right there. So we're going to take the antiderivative of u to the 1/2 power, antiderivative of u to the 1/2 power du, and crank that out. That's going to be what? Going to have 1/2 plus 2/2 is 3/2 over 3/2, right? So let's take that. That's going to be u to the 1/2 plus 2/2 over 1/2 plus 2/2, which is equal to, take that 3/2 right here, break it up, it'd be what, 2/3? 2/3 times u to the what? 3/2? And now what do we do with the u? Plug it back in and go ahead and use this. This is exponent over index, so that is the cube root of the square root, the cube root of this squared, exponent over index, sorry, the square root of this cube, so that's going to be 2/3, and rewrite it as the square root of 1 plus x to the x squared, sorry, to the 3rd power plus c. And that should be what they got. Yep. Right there. 2/3 x squared plus 1 to the 3/2. Is that what we got? Okay. Alright. So let's try another one. Capiche? Let's try one that I've already pulled out of another book. How about f of x is equal to 1/5 times x squared plus 1 to the 5th power plus 3. All right, take a second and work on that one. Yes. But to understand what we're doing, take the derivative first. Take the derivative and you'll come up with I'm just trying to show you the how substitution works, and you'll see in just a minute after we do it. So if you took the derivative of this, just take the derivative using your chain rule, that goes to 0. You're going to get f prime of x is equal to, bring that out, that's going to be 1/5 times what? 5 times x squared plus 1. 5 minus 1 is what? 4. And then what's the derivative here? 2x. Okay? Now clean that up. And when you clean it up, of course the 5 times 1, that's going to be 1. And then you're going to get x squared, blah, 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 2x. So that'd be f prime of x is equal to 1. I'm just going to put 1 there. X squared plus 1 to the 4th power times 2x. Now, I want you to take the antiderivative of that. Kind of like the problem we just did a while ago. Take the antiderivative of this. And then you'll see what I'm getting at. So you have to antiderivative of x squared plus 1 to the 4th power times 2x dx. So what is u? X squared plus 1, because this is the more difficult term. This is the easy term, that's the more difficult term. So I'm going to say u is equal to x squared plus 1. Therefore, du is equal to 2x dx. We have that. So what do we have? We have the antiderivative of u to the what? To the 4th du. So that basically comes up to, sorry. What's the antiderivative of u to the 4th du? U to the what? 5th over what? 5, which basically comes up to be 5 over 1, comes up to be 1/5 u plus what? Plus c. Well, what is 1/5? What is u? U is equal to x squared plus 1. So that gives us 1/5 times x squared plus 1 plus what? And what did we start with? What? Oh, sorry, yeah, to the fifth, sorry. What did we start with? See it? So we started with f of x. We took the we took the derivative of f of x, and that gave us this. Then we took the antiderivative of this using substitution, and it gave us what we started with. And that's kind of a little proof to show you how U substitution works. Okay? Question? Question on that one. Do you remember U substitution? Remember it a little bit? All right, let's work some problems. If the book doesn't blow up, hopefully we won't blow up too bad. All right, let's take something simple like this one. Square root of 2x plus 1. Start off simple. Square root of 2x plus 1. Take the antiderivative. Antiderivative of square root of 2x plus 1 dx. Sorry. Mouse is terrible to write with. Of course, if I got any mouse artist in here, y'all come on up and do this for me. All right, I'm gonna let y'all do that by yourself.
Priority 1 message coming in on secure channel.
Oh, I might turn it back on. All right, so in this case, you got the antiderivative of blah, 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 blah. And we're going to take this piece right here. Of course, we're going to change this to u to the 1/2 power to do that. So the antiderivative of 2x plus 1 to the 1/2 power dx. U is equal to 2x plus 1 du is equal to 2 dx. What's the problem? There is no 2 dx. And this is the part that you need to remember. This is the part that you need to knock cobwebs off of. Is we're going to take. In CAD, you would go this way if you want this piece. But no, not in this lifetime. I have to erase it. So we're going to have to move this over. And always dot it in. Now hopefully, if you haven't had Calculus 1 in a while, you're saying to yourself, oh yeah, I remember to do that. And that's the whole point of me showing you this, just so you remember to do that one thing. So now we have 1/2 u what? U to the 1/2 du. And what does that give us? That gives us 1/2 u to the what? U to the 3/2 over 3/2 plus c. And this 3/2 is going to be what? 2/3. So that's going to be what? 1/3. So we get 1/3 u to the 3/2 plus c. And that comes out to be 1/3. And u is 2x plus 1 to the 3/2 plus c. That should be your answer. And they got 1/3 2x plus 1 to the 3/2 plus c. Now there's another way to do it. And how is the other way to do it? Well, the other way to do it is to say u is equal to this whole piece. And if that's equal to the whole piece, then you can say du is equal to dx over that, and then you can solve. It's just an observation. It's not anything detrimental. But let's try another example that they start off with. Let's try that one. X over 1 minus 4x squared. X over the square root of 1 minus 4x squared. Give y'all a second to write that down, and then I'll write it down. X over the square root of 1 minus 4x squared. X over the square root of 1 minus 4x squared. X over the square root of 1 minus 4x squared dx. Little tricky. You ever heard the saying, you got to crawl before you can walk? Well, in integration with substitution, very true. It's about like derivatives. You got to be able to do the basic derivatives before you can do the more complicated. Well, this is the same exact, with integration, just basic integration, you don't have a problem with that because you just raise it x to the fourth and then that'd be x to the fifth over 5. But that's not what we're doing here. We're doing a little bit more intense integration. Antiderivative of x over 1 minus 4x squared to the what? 1/2 power dx. I'm just going to turn it around and I'm going to say x over negative 4x squared plus 1 raised to the 1/2 power dx. So let me just move all this over. It'll let me. So I'm going to make u equal what? Good. Negative 4x squared plus 1. Therefore, du is going to be equal to negative 8 what? Negative 8x dx. Is it important for you to write it as negative 8x dx? Yes. Why? Because you need to match this up with this right here. So it might behoove you to take this guy, put it right here. Because now, what do you need? You need a negative 8. Well, if you need a negative 8 in here, let me just rewrite it over here. X dx over 1 minus 4x squared to the 1/2 power. If you need a negative 8 right here, what do you need out here? Negative 1/8 out there. Sorry. So now once you have that, you have negative 1/8 times the antiderivative of what? du over u, or u du, and bring this up. So negative 1/8 antiderivative. What? No. I must be fighting over there. Bring this up. U to the negative 1/2 du. So basically you have du over u to the 1/2. So bring that up. And negative 1/8 brackets u to the what? U to the negative 1/2 plus 2/2 over negative 1/2 plus 2/2 plus c. And that's going to be negative 1/8 times, and this right here is going to be 1/2 But when you bring it up, it's going to be multiplied by what? 2. And then this is going to be u to the 1/2 plus c. And 2 over 8 comes out to be what? Negative 1/4. Operation. So this comes out to be negative 1/4 u to the 1/2 plus c, and negative 1/4, and u, what do we say u was? 4x squared plus 1. So 4x squared, yes, negative 4x squared plus 1 plus c. What's kind of important to do in these problems, especially if you're knocking cobwebs loose or you're relearning it for the second time, what's kind of important for you to do? Every step. Okay? Kind of helps. Let's see what they got. Is that the example we just did right there? Is that it? Yeah. Okay. Negative 1/4, negative 4x squared plus 1 plus c. How you feel? Feel good? Let's try some. Let's try. We could try this one. Let's go ahead and work with this one though. Example 5. The antiderivative of 1 plus x squared times x to the 5th dx. Try it here. The antiderivative of the square root of 1 plus x squared copy it. The antiderivative of the square root of 1 plus x squared times x to the 5th dx. No one for this one. I thought that would. Alright, let's rewrite it. So that's going to be 1, I'm going to change it to x squared plus 1 to the 1/2 power x to the 5th dx. Alright, take a minute and work with it, see what you come up with. Now this one you're going to have to do a little thinking, because the x to the fifth don't make things nice. So we could erase the fifth power. We could do that. That'd make things easier, wouldn't it? Let's just do that. Let's just erase the fifth power and do another problem. No, you can't do that. But you can think. Think in terms of x to the fourth. X to the fourth instead of x to the fifth. Rewrite x to the fifth as x to the fourth times something. That might help. Try that. Rewrite x to the fifth as x to the fourth times x. Antiderivative of x squared plus 1 to the 1/2 power times x to the fourth times x dx. Now the reason you did that was for a couple of reasons. One is the derivative of x squared plus 1 is 2x dx, right? Well, we got an x and a 2, bring a 1/2 out here. But we have a problem with this x to the fourth. So you need to think, is there anything in here I can rewrite as something squared and use the x to the fourth to that advantage of being something squared? So take a second and draw your 2x right here and 1/2 out here, but then think of this. This is x squared raised to the second power. Think in terms of that. And see if you can back it in, because that's basically what you're doing. u is equal to x squared plus 1. Therefore, du is equal to 2x dx. And from here, you can go several different directions. From here, you can say 1/2 du is equal to x dx. And then you could say x is equal to 1/2 du over dx. Or you could say dx is equal to 1/2 du divided by x. There's several different ways you can go here to help you get to that x to the 4th. The x dx is over there. That's not a problem. But that x to the 4th, keep working with it because you might start to see the actual relationship. Could take this one right here and rewrite it as x squared is equal to what? Couldn't do that. X squared is equal to u minus, bring that minus 1 over. X to the 4th, x squared. How can I make this equal to x squared? Raise both sides to the what? So what does this equal? X to the 4th is equal to what? U minus 1 raised to the what? Second power. That might help out. If you're using substitution, that might help out tremendously. So now you can put that in there as u minus 1 quantity squared. And I'm thinking out loud to myself because you also could take this right here. You could take this and plug that in, x dx right here. See? So now you can plug this in right here and plug this in right here. And you got it made. And then you feel good about yourself. So, this is u to the what? 1/2. Everybody with me? X to the 4th is what? What did I tell you x to the 4th was? u minus 1 raised to the what? Second power. And then x dx is equal to what? 1/2 du. Good gracious, it looks like we got everything in terms of what? Wow, now we can do our algebra. Dang old shortcut number 2 right here. U squared minus 2u plus 1. And we'll multiply that through. So do algebra. Y'all should be happy. Got everything in terms of u. Oh me. Y'all just not into it today or what? Just one of those mornings. Y'all wanted this to be an easy calculus day? Is that what y'all wanted? I'm sorry. I don't know what's gotten into me. Now, this type problem, the reason I'm showing you this type problem is here you're given this and you see this, and right off the bat, what did you say about this guy right here? This one is going to cause what? Trouble. So you erase the little fifth power and then you do another problem, or you just quit, or you take this out and you put it in relation, well, put it in relation to something like this. You rewrite it. In other words, when you have something that looks like it's going to be trouble, you don't just quit, you rewrite it. Now, why didn't I write it as x to the third times x to the second? That wouldn't have helped anything, because what? You wanted to get some kind of x dx right here. That's why. And then when you do u is equal to x squared plus 1, you get some things over here that can help you with substitution. So, let's take that over to another page. And that's going to give us the antiderivative of u to the 1/2 power times u squared minus 2u plus 1 1/2 du. And then that u to the 1/2, take that through. That's going to be the antiderivative of u to the 1/2 times u to the 4/2 minus 2u times u to the 1/2, and that's 2/2, plus 1 times u to the 1/2, and all that 1/2 du. So that's going to give us the antiderivative of u to the 5/2 minus 2u to the 3/2 plus u to the 1/2, 1/2 du. What do we have now? You just have a basic what? Collection of terms, right? Break it up into 3. So go ahead and do it. You might have to do a little bit of substitution, but go ahead and finish it out. That 1/2, what could you do with that 1/2? Like any constant, what can that 1/2 do? Pull it out. And then you've got a regular antiderivative problem. Bring that 1/2 out. Antiderivative of u to the 5/2 minus 2u to the 3/2 plus u to the 1/2 du. And that's going to be 5/2. Good gracious, you're going to take that over to the next page. One half, and I'm just going to put brackets here. U to the 5/2 plus 1/2 over 5/2 plus 1/2 minus 2u to the 3/2 plus. Did I do 1/2? I think I did 1/2. I should do 2/2, right? 2/2 over 3/2 plus 2/2. Y'all too quiet, bothering me. U to the 1/2 plus 2/2 over 1/2 plus 2/2 plus C. One half times 5/2. That's what, 7/2, which is 2/7. 2/7 u to the 7/2 minus 5/2, which is 2/3. I'm sorry, 2/5. Right? 2/5 times 2, which is 4/5. I'm trying to save a little bit of space here. 4/5 u to the 5/2 plus 3/2 would be 2/3 u to the 3/2 plus c, and 1/2 would give us 1/7 u to the 7/2 minus 2/5 u to the 5/2 plus 1/3 u to the 3/2 plus c. And what's the final step? Plugging in what? What's the last step? Plugging in u. So check it to see what they got. They might have plugged in u. I did. Excuse me. Check to see that we got the coefficients right and the exponents right. Yes, no, maybe. 1/7, 7/2. Did we get? Yeah, we got that. Negative 2/5, 5/2. then 1/3, 3/2. We're cooking with peanut oil, ain't we? Y'all don't sound too convinced. Why are y'all so quiet? Talk to me. Y'all just don't want to talk to me this morning? Y'all want to ostracize me, cast me out, don't speak to me? Is that what it is? Okay, that's fine. I'll just get Mohammed Gobadi in here to help y'all out. Huh? No. Alright, let's try a couple out of the homework in here. Well, we can do tangent. Let's do tangent. Calculate the tangent of x dx. The antiderivative of tangent of x dx. Calculate the antiderivative of tangent of x dx. Now, you know they want you to do something. Antiderivative, tangent x dx. Now, from your trig days, how can you rewrite tangent? Sine or cosine. That's what I would do first. Antiderivative, sine of x over cosine of x dx. That's the first thing I would do. I mean, of course, you could use your rules and say, okay, the antiderivative of tangent of x is, but that's not going to, they're not asking you to do that. They want you to do it by hand. They want you to derive it. Okay? Now, ask yourself this. What's the derivative of the sine? The derivative of sine is cosine. The derivative of sine is cosine. The derivative of sine is cosine. So what is this? If u is equal to sine, then what's this? Du. So you've got, technically, you've got u over what? What's u over du? What's the antiderivative of u over du? Think about it. Or work with it. This is only 2 or 3 steps. Not very difficult. If u is equal to the cosine, you could do u is equal to the cosine, then you have, you still have du over u. Yeah. Or 1 over u. Yeah, du over u. I'm sorry. I had it backwards. Yeah. The du over u. Sorry. Du over u. So you could rewrite this as the natural log, but if u is equal to cosine, what's the derivative of cosine? The what? Negative sign, right? So there would be a negative out front to go with that guy right there. So we have basically, what do we have? We have the natural log of what? 1 over the what? 1 over the cosine, the negative natural log of 1 over the cosine of x. And what's 1 over the cosine? Huh? Secant. Natural log of the secant. So that's just a little derivation. Of course, they don't want you to memorize the derivation. They're just showing you how they got the rule of the antiderivative of the tangent is the natural log of the secant. And you probably need to put your absolute values there, but and it should be what they got. Except it's not the negative, sorry. I got that mixed up. And then you can put absolute values right there, yep. Because you can't take the natural log of a what? Dang old negative. Again, they're using substitution. And that's all they're trying to get you to see is substitution. Let's go to your handy dandy let's go ahead and create assignment. We're going to call this assignment count review. We'll call this antiderivative sub. Yeah, that made him mad. He's leaving. I don't blame him. See, he's quitting. All right. Huh? This thing's gonna drive me freaking crazy. Okay, I clicked it. Are you gonna work or what? Thank you. That's not right. I'm starting off with these. That one's pretty simple. I'll give you that one. That one's kind of like the one we just did. I don't think I'd give you that one for the first one. Give you that one to work on. Oh, not too bad. Okay, I'm sorry. This feels like I'm at the end of the chapter. It doesn't feel like I'm at the beginning of the chapter, which... Huh? There should be some easier problems than this, but... Okay. Let's work a couple of those. Okay. I have to do all this. I can't just go into a problem. That would be too difficult. Okay, open student view. Thank you. Alright, let's do that one right there. 5 plus 6x to the third power times 6 dx. Try that one. Antiderivative of 5 plus 6x to the third power times 6 dx. Alright, y'all are doing that. I got to update the attendance because I had a few people come in. A few losers come in late. I'm sorry, a few people come in late. I don't understand people coming in late. We were all here on time, weren't we? Didn't I tell y'all to get some Mountain Dews and coffee and mix it together? Didn't I tell y'all to do that? Huh? Well, you need another cup. You're not talking. Alright, Mr. Fowler came in. Who else came in? Mr. what? Urban. Anybody else? Okay. There is a fan in our AC system. Can y'all hear it? Yeah, it sounds like a cricket. Oh, it was worse yesterday. Yesterday it sounded like we had crickets in the building. Oh gosh, you should have been here yesterday. You would have left. Well, where is... Alright, first thing you do is, I would rewrite it. Just me. Antiderivative of 6x plus 5 raised to the third power times 6 dx. U is equal to 6x plus 5 du is equal to 6 dx. So do we have 6 dx? We already have it. So that's u, antiderivative of u to the third du, which is equal to u to the fourth over 4 plus c, which is going to be equal to 6x plus 5 raised to the fourth power 1/4 plus c. Is that what y'all got? Say again. Well, you got to crawl before you can walk, and I don't know how much y'all have had with substitution. So 1/4 parentheses, 6x plus 5. I don't type on this thing very much because I am going to warn you. Those of you who have not used WebAssign before, can you type in the exact answer and it mark it wrong? So I'm just telling you. Don't go in. Is that when you're supposed to go into Hammy and start having convulsions and start calling me and sending me 15 emails? Or should you just wait for class? Wait for class, because it's not a big deal. I'll change it. No big deal. Okay, it'll take a couple of minutes. Hey, we got it right. We feel good about ourselves, so we don't have to put smokestacks on our truck. Right? All right, let's do nerding. Let's do that one. And I'll see if I can find some more to put on your homework because I didn't like the way I didn't like the ones I saw, huh? Huh? Well, I figured some of y'all might want to do, challenge yourself. No, you don't want to challenge yourself. Okay. Car goes over bridge falls. It don't matter. You already got the smokestacks. Okay. I always ask people who have smokestacks, what's the advantage of having smokestacks on your car? And they'll say it gives it more power. I say no, it don't. You got a Dodge Stratus, okay? Then it would give it more power. People are stupid. And I'm sorry if you have smokestacks on your vehicle, you're stupid because there's no use for it. Mr. Fowler, you had it, don't you? I figured you did. Yeah, with a 4-banger. There was one here a couple of semesters ago. He was parked down here. He was in a Ford Ranger, like an 84 Ford Ranger. And it had a pipe coming out of the back, and it was a 4-banger. And he would park down here, and he would cross park so nobody would park beside him because of that fine vehicle. I believe he had a hatchet or a girl in the back of that thing covered up or something. I don't know which one it was. Oh. All right, here we go. The antiderivative of x squared minus 4 to the 5th power, 2x dx, u is equal to x squared minus 4 du is equal to 2x dx. And we have that. So we have the antiderivative of u to the 5th and du. So that's going to be u to the 5th, u to the 6th, over 6, which is going to give us x squared minus 4 to the 6th power, 1/6, right? Yeah, plus 6. Now, there's two kinds of people here. There's two kinds of people in the room right now. There's people that's saying, oh God, this stuff is easy, I had it last semester. And then there's some people that's going, I know what we're doing now. Okay? And if there's anybody, one person in here saying, I know what we're doing now, then it was worth the whole time for me to go over this. Because I'm not here to teach what you already know. I'm here to teach ones that don't know. So, hopefully there's at least one person out there. Mr. Fowler, right? Okay, good. All right, good. There's one person out there. I'll pay you afterwards. All right, x squared minus 4, blah, 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 blah. So, 1/6. We'll make that a fraction. 1/6, parentheses, x squared minus 4, close parentheses, raised to the 6th power. Is that good? And submit answer. Wait a couple hours. And we got that one right too. So we're batting 1,000. We need to get discouraged somehow. Alright. Try that one. They even gave you a hint. E to the negative 12x dx. So, antiderivative of e to the negative 12x dx, and they even give you a hint. U is equal to negative 12x, so du is equal to what? Negative 12 dx. So they know negative 12 here and a negative what? One-twelfth there, Hubert. That's right. So what do we have? We have negative 1/12 of the absolute value of the antiderivative of e to the what? What is this in relation to this? U is equal to what? Negative 12x. So that's e to the u what? du. And what's the antiderivative of e to the u? So what? It's e to the u, isn't it? Simple. So negative 1/12 e to the u du, and that's going to be u is negative 12x. So that's negative 1/12 e to the negative 12x du. I'm sorry, let's see. Can't believe y'all don't want to challenge yourself. That was a challenge. Y'all suck. Negative 1/12. Oh, okay. E to the negative 12x. Nope, that's not going to work. Hey, what are you saying? What are you trying to say? Yeah, right. Wait till we get to the stuff that ain't reviewed. You're gonna be hating life. Uh-oh. Oh, bump them. Plus C. See what they do is they put plus C on everything, and then they don't put plus C and they mark it. Bump them. Oh yeah, whatever. Yeah, you got to use capital C. All right, I'm going to let y'all do this one, and then we're going to let y'all go because I got to go to the dentist. So I'm going to let y'all do this one. Do this one, and we're going to finish for today. And I ain't forgot about your question. Just send it to me, okay? And we'll go over it next time. Yep, this is the absolute value. Oh gosh, this is one that we did a while ago. Absolute value, may not have enough time to do it. X squared times x cubed plus 35 dx. Well, they're giving you a hint, but we were going to make u equal that anyway. So it's not going to be that bad. Antiderivative of the square root of x cubed plus 35 x squared dx. U is equal to x cubed plus 35 du is equal to 2x squared. I'm sorry, 3x squared. 3x squared dx. So what do we need to add? The 3, Hubert. That's right, class. So we have 1/3 the antiderivative of u to the 1/2 du, and that's going to be 1/3 u to the 1/2 plus 2/2 over 1/2 plus 2/2. And 1/2 plus 2/2 is what? 3/2. 2/3 be what? 2/9. 2/9 u to the 3 halves, which will be 2/9. And what's our u? X cubed plus 35 to the 3 halves plus 3. Oh, I gotta hurry. I'm gonna be late for my dentist appointment. It's all because of y'all, because I sacrificed for y'all. What? It's all Bush's fault. There you go. Y'all are learning. X cubed. Yeah, I'm teaching you something. Plus 35, close parentheses, raised to the 3 halves, plus what? Plus capital C. Did we get it right? Okay, now that I've done all your homework for you except for one problem, hopefully you can go home and do your homework. All right? I'm going to add some more though.